All right, so for those listening for the recording, we just started recording now, and we just started going through the first assignment. So the first graph is just sort of showing an initial take of a bar graph looking at employment by state, and then we were just talking about how it's useful to order bars to just add a bit more information without really adding any more ink. It's just sort of a reorganization of the visualization that is allowing ranked questions to be answered in a quicker way. Um, so, so basically, so showing it like this, you would be able to sort of have things ordered, and then I'm using chord flip here to have this more oriented for a vertical orientation. If I had made this as a standalone, it would sort of stretch to whichever viewport really it's using. So Jim, to answer your question about how to make sure how to make the y-axis bigger, there are ways of setting, I'm not remembering the syntax off the top of my head, but Jim, if you ask that in the Ask the Instructor forum, I'll post the syntax and find the way to do that. But there should be ways to, there are ways to hard code the height and width, but usually I don't like using those. If so, in a question like this, it's specifically saying that it's being consumed in a certain medium, and the fact that it's being consumed in that medium would sort of allow for the visualization to reorient itself depending on how it's being created. So usually like ggplot, plotly, they're really good at matching whichever window, whatever frame it's being put in. So something like that isn't really you are able to sort of fix your heights and widths, but especially as we kind of move on more towards shiny and dash, you're really having responsiveness is something that you don't really think of as you're using as you're sort of looking at a web page and seeing how it's laid out. But there's sort of a lot of dynamic calculations. There's a lot of dynamicness that's needed there. So dynamism. So you'll be able to kind of I like sort of leaving things open-ended in that way. And then Sergio asked about taking the background grid. So there's so that is a good point that taking out the background grid makes it a bit harder to kind of map the exact numbers to the x-axis. And there are a few ways of dealing with this. I don't think I'd be able to find it quick enough, but there's in one of Tufte's books, he actually adds the grid to the bars. So one strategy he uses is you could sort of imagine just every 100, for every 100 count, you would see sort of a white line here, white line here, white line here, and it only affects the bars. You're actually technically taking away more ink, and that's a way of sort of having the grid be a part of the bars. That's a pretty novel strategy, although to my knowledge, it's a bit hard to really implement in packages. I haven't really seen out of the box options for that. And then one other option is having the values actually in the bar chart. So displaying kind of the displaying the actual numbers just in the bar chart. That actually would work really well for a vertical bar chart where you're kind of viewing it in the correct orientation, so that something like that would work out really well. Cool. Cool. So any other questions on this before we move on to the next question? Cool. So John added the comment that the visualization should be communicating disparity. By that, do you mean, and John, I don't think I got up to your homework yet, but by that, do you mean like sort of showing how much bigger, how much more employment California has versus the rest, or sort of uh, something like that? And if you're typing that up, I'll just add that we'll, yeah, so, okay, now I see what you're saying. So, John, yeah, the disparity you definitely get without having to, really get the exact numbers. So, you could see that this is above 600. It might not be important if you're getting the exact number that it is, but you do as you mentioned, you do get the disparity. So you are able to pretty clearly see that California is kind of an outlier in terms of employment. It's just that much more of a populous state, so there's definitely correlations there, but you're able to very clearly see that. So, you may not be able to get the exact numbers of California and Texas, but you're able to very clearly see that Texas is about a little more than half of has about half the employed people as California does. So, something, and then that maps back to what we were talking about in our first meetup about how using, length, you're really able to see you're really able to clearly make those sorts of comparisons. Cool, but good comment there. So for the first question, we're specifically tasked with looking at the number of employed people, looking at employment per state, and the one thing about this sort of data exploration that I wanted to really highlight comes about in question 2. Need to correct that. So for question 2, we're beginning to dig into what actual data is underlying. So we're looking at the state with the third most companies, and in this instance, we're looking at how many people are employed by companies in different industries. And you'll see sort of in the prompt here, we're looking at things like average and or median employment, and in addition, we're also trying to get an idea of how variable the ranges are. So so basically here, we are looking for an aggregation, but we're also looking for more than this data is giving us, than this question gave us. So here, we are also looking at an aggregation. We're looking at counts, and we specifically asked for counts. So so something like a bar chart where you're just showing those that one value makes sense. And in terms of this sort of data exploration, scatter plots are really one of the best ways of just exploring these sorts of dynamics. So in particular, like a scatter plot will give us the variability of ranges, and will give us an idea of what's happening on a company by company basis. So so here So here we're looking at our companies, and we notice a few things. So first, it's pretty clear that we have two outliers, and we're going to it would be best to try to find a way of dealing with that because these two outliers showing here, we're really losing any information about what's happening in sort of the vast majority of companies in these industries. So the first thing that we could do, and there are a few ways of dealing with outliers in the homeworks that I've checked. Some people had a different approach than what I'm using here. So what I'm working with here is just simply clipping the data. So I'm just sort of picking a sort of bottom value and a top value, and I'm pretty much just returning if if it's above that top value, I'm returning that top value. Otherwise, I'm returning the actual value. So essentially, what we're doing is we're just kind of moving these outlier companies to sort of a more reasonable scale. So we still have our outliers. In this case, we actually have three. So there's a third outlier that's being that's sort of being clipped there, and here, you could sort of think of this as another version of what we were looking at up here, where we where sorting the bars, we're not really doing anything in terms of the data ink ratio, but we're just really by using sort of uh, this this simple tactic, we're increasing the readability of the visualization. And similarly here, we end up this is actually a trade-off because we are technically losing information. We're not showing where these companies are graphically, but we're just gaining that much more information. We're sort of sacrificing the information that we could have gained with these two, and just gaining so much more information um, with the bulk of companies. And you'll actually notice that the that clipping the data, we do get a better idea. There is still a kind of clustering of companies that is happening, sort of towards the lower lower employment numbers here. So does anyone have an idea of what that sort of suggests about the data? Like if you begin kind of moving either clipping your data in this way, and you still end up with clusters towards the lower numbers. Does anyone have an intuition about what that might be saying about the distribution of employment? Yep, Jim, you got it. So there's a skew there, and a lot of times that could suggest some sort of distribution, like a yep, and Gracie, exactly. So here it's kind of on the fence. I decided to stick with this clipped version. I saw a couple of other people in grading. They ended up doing a log transformation, which definitely helps sort of deal with these sorts of issues. One rule of thumb I kind of think of when looking at questions like this is, if you find yourself kind of, continually clipping the data and still finding yourself compelled to clip the data more, you kind of want to stop that process after a bit and just begin to think about something like a log transformation, which would deal with sort of prevent that sort of clipping. Because you can imagine, like, maybe I would have seen a distribution like this and think I still want to get more information here. Maybe I want to clip at 1,000, and at that point you really begin losing. The trade-off stops working in your favor. Like after one or two times, you don't really want to be clipping your data anymore. But at this point, I thought something like this worked out fine. And I just realized I left that part there. So basically, you know, looking at things in a scatter plot, this is a really good kind of iterative, exploratory way of looking at the data. But if we wanted something like this ready for um, consumption by sort of another user, if we were creating this visualization and wanted other people to draw conclusions from it, there are a few other ways of displaying this data. And I left this over here, but distributions are pretty nicely shown by box plots. So with box plots, we're able to see see the medians, see the interquartile range, and then see the see whiskers going out to, I believe, 1.5 the interquartile range, if I remember correctly, and then getting dots for any other distributions and for any other outliers. And looking at it in this way kind of gives an interesting picture as to what's happening. So we very clearly see the skew that Jim mentioned, that we definitely have this sort of right hand skew. We so you're able to see that, and you're also able to see that this is different for each of the industries. So we have some industries that are pretty tightly packed, and then you have some other industries where they're just larger companies. So this kind of gives a bit more texture as to what's happening with these various industries. And then lastly, this is just sort of the section here that's labeling these outliers. So this is a way of getting that information, sort of trying to save that information. So we, are able to kind of just add some labels and just get that additional context, so that we're able to see that this is actually 32,000 without having to mess up our scale. You wouldn't have to do something like this with the log distribution. However, the downside of using a log distribution is, log distribution is a bit less immediately intuitive. Like if I look at, let's take human resources as an example. If I look at this box plot, I am pretty, clearly able to see that it's, there's a lot of data points sort of on the upper end of the distribution. I get that sort of context pretty clearly. And with a log distribution, you're able to compare it to others more easily. You actually will get more information. So no matter how we clip this, we're always going to end up with kind of less information about the lower values. So you will get more information about that. But there's sort of, you sort of lose the ability to kind of one-to-one map that, kind of like if you see a distribution, it'll look more even, and you kind of need to take that extra cognitive step of thinking, this is actually a log scale and something else is going on. So again, there are trade-offs with all of these rules. None of these are really meant to be kind of hard and fast. It's more, kind of judging depending on each context that you're looking at. And then I just included a few other examples here. So box plots are, ggplot has them out of the box. They're, and this is something that it's a fairly standard visualization type, but ggplot also allows you to get creative with how you want to display this sort of data. So using something like this, just representing means with points and representing ranges with bars, so sort of looking at this, thinking of this in terms of, error bars or something like that. Um, ggplot allows you to do something like that. So, here it involves a bit more work. We need to, manually sort of get the stats that we're looking at. So here in this case, I wanted to, just show one standard deviation, and then look at the different medians. So, and I'm sorry, I'm using a quantile. So this is just purely the interquartile range that we're showing. And then, looking at something like this, you need to kind of calculate all of that. But once you do, it's, just using kind of basic ggplot, sort of concept. So using this geom point, and then the sort of error bars, the geom point range. And then lastly, this is just another way of showing this, but if you wanted to stick with bar charts, you could just simply add these error bars to bar charts. So, really what this is showing is just kind of the question, the question was getting at, we're looking at sort of ways of visualizing a distribution, and, there are kind of pre-canned ways of doing that, but there are a lot of when you sort of just begin conceptualizing how it is possible to look at things like this. Something like error bars, usually they're used in different contexts, but here you're able to use it to view a distribution. So any question on question 2 before we move on to question 3? Cool. So for question 3, we're sort of imagining looking at a different measure. In this case, we're investors and we're looking at revenue per employee. So we're looking at employee productivity. And in this case, we're sort of looking, looking for this information, and then because we're looking at sort of the by company distribution, this is by company, we want to also get an idea of the distribution per industry. So this one is pretty similar to what we have with question 2. So we are able to view, so we are able to answer this using a similar strategy that we used above. So here I didn't clip it just yet, but we first need to calculate our revenue per employee. So, we need to do some transformations of the data, and then I should have removed that. And then we we would just simply add this to a box plot. So looking at the box plot, we end up with something looking similar to what we had above. But for this question, I wanted to really highlight a couple of other another way of looking at these distributions. So here, one example, here sort of another method I'm using is what are called kernel density plots. And ggplot has this as a built-in aesthetic type as well. So we're looking at geom density. We're looking at our, here we're sort of using the principle of small multiples. So we're going to be using a facet wrap. And lastly, we're adding a log scale so that we're able to get a clearer idea of the of sort of comparative differences. So, here we're kind of losing with the log scale, as I mentioned above, we're losing sort of, some like some, sort of the log scale makes a lot of these look like bell curve, look like sort of normal distributions, normalish, and that's not in actuality what's happening. So you lose a bit of context there, but this really let us compare these things more. So you're more clearly able to see something like health, where you have a very narrow distribution, and then government services, for example, where you have a wide distribution, or even things like real estate, where you have a bimodal distribution. And for these comparative purposes, using a scale like this kind of lets you view those sort of make those comparisons. And something like this, if you've come across violin plots, this is actually what it's using. It's using this kernel density estimate, and it's really a sort of smoothing function that takes some sort of distribution and kind of reduces that to a curve like this. So did anyone else have any, from the homeworks I saw, I mentioned a few of the variations I saw. Did anyone else have any alternative approaches to working with this? Or any other general questions about this assignment? Perfect. Cool. So with that, we'll move on to module 2. And so for this, I'll just sort of go over what the template has, and kind of talk a bit about what's going to be expected here. So with the notebook template, this is something that similarly to the R Markdown template, you'll be able to pretty easily build off of. The for this module, we're sort of doing two things. We're looking at visualization in Python, but we're also looking at sort of how strategies of dealing with larger data sets, and the two kinds of approaches we'll be looking at are different, more creative bidding and aggregation strategies, and then using the data shader library, which is a really cool library that kind of automatically takes care of all of these sort of all these concerns for you. So the data that we're looking at is a data set called Pluto, and we'll have to change the file some of the file names here, but I was using an older version when I had that. But so this new version is 18, so just keep that in mind. But the files are a bit too big to just upload to GitHub, so just download them and make sure that you have your paths correct, and you'll be able to sort of read all of this in. So what we're doing is just concatenating all of the CSVs. So it comes in different Barrow files, and we're going to be and then just getting rid of some weird outliers. So we have some very very old buildings, some 0 years where the year isn't known, and for some reason there's buildings that are showing up that haven't been built yet. So there's so this is just cleaning up the data set in a bit, but you'll one of the challenges that you'll notice with this module is this isn't the cleanest data set. So there are intentionally some challenges to deal with here. And I didn't get through explaining Pluto, but Pluto is a database of every single tax lot in New York City. So you're definitely a sort of larger data set that will sort of require some thought in terms of answering the questions put forth. And here I just did some work with sort of translating the latitude and longitude into sort of translating the projection into latitude and longitude. They have some state-specific coordinates, and this is something that was, I remember when I first tried to figure it out, it was kind of difficult to locate, so I didn't want people getting tripped up there. And this isn't a GIS course, so so here you'll have the latitude and longitude, and that geographic component will be using in the data shader portion of the assignment. But to start out with the first question, really what we're looking at is just kind of traditional ways of dealing with large data sets. So one of the examples I like bringing up is so this is a Plotly example about sort of how Plotly handles large data sets. We actually have, with the newest version of Plotly, you're able to do some integration with data shader, so that's pretty cool. But this is kind of just a more kind of naive approach to plotting large data sets. So if you have something like 100,000 points or 1,000,000 data points, you may one of the first things you'll do, like if you're following the ETL, the exploratory strategies that we were using before, you may just want to throw them into a scatter plot and see what's happening. And when you are doing that, here this is just using 100,000 data points, and really there's a lot of there's a lot that's lost. So pretty much you kind of see a pretty well-defined edge, and once we reach that well-defined edge, we begin losing we lose any information about sort of what makes this region different from the central region. We're looking at two normally distributed variables, so so we're getting kind of a 3D normal distribution here. We should be seeing more points clustered in here. So this is kind of an example of how most graphing packages, things get different when you're sort of moving to truly big data. But if you're dealing with this sort of medium big data, a lot of the graphing packages that you'll be using can handle it. But the question then becomes, is it really achieving its aim as a visualization? So here there's some like Plotly is interactive, so you have some benefits from being able to zoom in, being able to pan, so you get a bit you kind of get a bit more context when you're able to work with the data in this way. But it's still not truly ideal. Like here there's still a pretty well-defined edge, and you begin losing information as you get to the truly dense spots. And there are, I'll get to that later. Basically, this is sort of, the challenge of dealing with large data sets. And the traditional way of dealing with this is just simply by aggregating. You can imagine something like this. You could just and actually, there we go. So here we have that we have a similar, binormal distribution, and we're binning the data. In this case, binning it by binning it in 2 dimensions, and coming up with a 2D histogram like this. And using this, we get similar to a lot of the concepts we were working with in the first assignment. It's kind of a trade-off. We are losing some information where, there's a resolution issue, and that's almost exactly how you should be thinking of it, that, we're sort of limited, we're not sort of getting information about every single point. But what we are getting is, we're not sort of, essentially the visualization isn't lying to us. We are able to, at the visualization that we're looking at it, see, there's sort of a center area, and see, sort of how things are dying off as you get towards the edges. And something like this, it is a trade-off. So again, no, sort of clear-cut rule. Sometimes, in some cases, it may make sense to display a visualization like this. So if you imagine that there was some sort of interactivity where you hover over individual points here, and you would be able to get information about whatever that point represented. Something like this might be useful, just simply as a way of highlighting the outliers. So here, you're losing information about the middle, but if you think of it, you are getting information about where the outliers are. And in a lot of cases, when you're visualizing data, the outliers are what matter. So if, imagine we're looking at, thousands, hundreds of thousands of hypothetical portfolios, and you're looking at sort of comparing returns to, risk, or, and you want to really, in a context like that, the outliers may matter more. So, you may want to kind of get more information about what's going on in those outliers. And, you lose that a bit when you have a 2D histogram. If you saw if you remember from the 2D histogram, you would see boxes here. Every so often there would be sort of a bit more shading, and that would suggest that there's an outlier there, but it's not giving you the same information that something like this gives you. But again, it's a trade-off because you're totally losing information about what's going on here. So if the goal is to surface outliers, something like this might be useful. Most of the time, you're going to want to be aggregating and binning your data. And so this first exercise, it's really concentrating on what does it mean when we're binning and aggregating. So looking at the 2D histogram example, that's kind of that's a standard type of visualizations. That's sort of more out of the box, but but binning could also result in just standard visualizations. So in this first example, we're going to be looking at buildings built per year, just to get an idea of how many buildings are built per year. And we And right off the bat, we sort of notice something weird is going on. So dealing with trying to find out what's happening there, that's going to be part of the answer. That's going to be part of the answer for the first question. And one thing I also included here is just some general notes on pandas, the since most of this course, most of the degree, the master's in data science, focuses on either R or being language agnostic, which tends towards R. There's, you know, I find that there's sort of not that much focus put on Python here. Do I use both R and Python pretty evenly, and personally, just sort of being client facing in my career, like I've seen Python out professionally, so I definitely want to make sure that there's sort of I make sure I get that Python exposure for my students, and so for people who might not be as proficient in using Python. This is just a cheat sheet on different concepts with Pandas. So in terms of everyone's experience with Python, everyone here should have done 602. Is Does anyone have sort of would you consider your Python experience basic? Like, do you have notebooks? I believe in that first Python class. I'm not sure how it's arranged now, but I don't know how heavy notebooks are there. But like, has everyone used Jupyter notebooks before? Or is there anyone who this is still might require some setup? Cool. Yeah, when did they bring it up in 602 now? Is it something that's do they cover Jupyter notebooks sort of from the beginning, or is it something that's introduced at the end? Okay, cool. Yeah, that's what I remember. I actually graduated myself years back, so I and then I remember it was sort of towards the end that Jupyter notebooks were brought up. And so if there are any questions on that, use the Ask the Instructor forum, and I'll sort of provide some more context there. And then this just goes through. This cheat sheet is really meant to be kind of pandas for the R data frame user. So it's very comparative, and it's I highlight a lot of the kind of conceptual differences because it's mostly the same. Like, these are all data frames, and you'll notice a lot is very similar, but there are some key differences. So, for example, in general, indices are more important in pandas than in R. And you'll so in general, that's kind of something to keep in mind, that it'll sort of like a lot of I've definitely run into a lot of sort of when I was first getting a handle on pandas, trying to perform things like merging or concatenations, and ending up messing up because of the indices. And I also sort of have some things that helped me out. So, for example, with group bys, it sort of automatically sets the variables that you're grouping by as your index, and it creates what's called a hierarchical index if you're grouping by multiple variables. So I just personally like doing a reset index, and it kind of brings back the tabular format, which would be more similar to what you're seeing in R. But and there are pros and cons to all of these. So I also mention there are some benefits to having indices, things like resampling. Pandas does very well with sort of time frequency, essentially aggregations, but when you're dealing with time, it's different than just aggregating by a categorical variable. So resample is pretty cool. And then check out the apply sort of function, because just the concept of being able to this is basically the analog to transform, but it's I found in Python it's a very powerful tool to help you out. And lastly, I think I included the link in the content section, but there's a book I recommend, Python for Data Analysis, and it's a cookbook style intro to pandas. And it's pretty freely available. Just Google the PDF and it should be there. And then running a bit out of time, but for question 2, we're for question 1, we're getting back to question 1. We're just looking at essentially how over time buildings have gotten taller. That sounds, and that's meant to be sort of something to really think about, like how would you conceptually show something like this? And really, kind of the way to think of it is, and here you could sort of glean this from the setup, where you're looking at older buildings, and you're trying to investigate these older buildings for safety. And if you think about sort of the first time a 12-story building was built, that first instance of a 12-story building, architects really haven't had as much practice in building these tall buildings. There may be some design features that were added as people got better at building 12-story buildings. And then similarly with sort of each level of tall buildings. So, really what we're trying to get at is when were those first few tall buildings built for each of these sort of groups of buildings. And here I sort of laid out like 20 to 29, 30 to 39, or 40 to 49. So that's the first question. And then to just quickly get to the second question, data shader. So what I went through before, aggregation is really the classic way of dealing with large data. You bin things and it lets you, kind of essentially decrease the resolution, but just, kind of get a summary of what's happening, what the overall shape of your data is. And data shader is it's a really cool library, and it's an attempt to essentially remove that, to do all that automatically. And it sort of looks at problems of, and I, by the way, I added these docs to the content. These were relatively new. They weren't here last semester. So that's good, because a lot of what they had before were just demo notebooks, which were useful, but it's nice to have things organized like this. And here we are. So data shader is organized around what they call plotting pitfalls. So the way to think of this is, if you imagine a visualization like this, you have overlap and you're losing information. Here, the example that they give is with sort of comparing different categories. So we have a red and blue category, and we want to view these two together. And depending on which color, the layer of the colors, we get different visualizations. So if one looks at this visualization, they'll say, there's sort of a region of blue here with kind of an outside region of red. Here, there's like a region of red here with an outside region of blue. But in reality, it's two normal distributions that are just offset by a little bit. And so in this case, this is something. Um, there was a talk I listened to a while back where this is really the visualization lying to you that the choice of which of these points to plot first should not be informing what the visualization looks like. Like, if that's happening, then that's a clear sign that the method that you're using isn't entirely being truthful. Something is being hidden. And there are a few strategies. So here and here, this talks about like what's happening there. And one strategy of doing this, which would work with the Plotly example as well, is sort of making things, adding some opacity, and you kind of solve that problem. So you'll get some purple to show the overlap, but there is still some difference. You could see this is a bit more red and this is a bit more blue. So there's still, there's still some lying happening with the visualization. It's still not really being true to reality. And so data shader looks at, and then this goes through a lot of other examples. So, undersampling. This is what I was explaining with Plotly, and then various things like this. Um, so read through these docs, and this really kind of, this plotting pitfalls really gives the motivation behind data shader. So really what it was meant to show is if you just so for part one, we're kind of looking at these limitations and using binning and other forms of aggregation to get around it. Data shader essentially allows us to just not even have to worry about that. So we could just throw our data at something like data shader, and it will, it'll deal with all of this automatically. And so here, for example, we're looking at kind of the first brush of the first question. So we want year built and the number of floors in each of these buildings. So a first step, and this wouldn't be the only step, but kind of the first step in sort of analyzing what's happening would be sort of just getting that XY scatter plot. And data shader, looking at something like this, kind of contextually changes its approach, its rendering approach, depending on what we're looking at. So we have a large number of shorter buildings, and it's using color scales to deal with that. And then for sort of the taller buildings where the outliers are important, it's more important to kind of be able to pick out when each, let's say 50 to 70 story building was built. It's showing points for that. And, data shader is doing this in such a way that you're not going to have to worry about these changes. And this is just a scatter plot. And then, one thing to just continue the context is data shader works really nicely with geographic information. So looking at latitudes and longitudes, we're able to sort of, because our points are so dense, we get a nice map that is showing us that is showing us just the density of buildings, which ironically, you sort of have low density of buildings in Midtown Manhattan just simply because that's where all the skyscrapers are, and that's just a bunch of huge buildings versus a bunch of brownstones that you would see in sort of Brooklyn or Queens. And then for this question, we're looking at we're sort of considering, like, we're a developer. We're looking at underbuilt areas of the city, and we're comparing things like we're comparing two dimensions. We're looking at how valuable the land is versus how valuable the structures are. And the way to conceptually think of this is if land is very valuable, it'll encourage a more valuable structure. So you have skyscrapers in central city, you have single family homes as you move further out. And something like this is really meant to highlight areas where there are single family homes, there are perhaps sort of underdeveloped areas where places that do have single family homes could sustain larger buildings. And it's helpful to have this sort of assessed land value versus assessed structure value. And in doing this, because we're looking at two variables, for the first question, it's similar to the first assignment where there's an open-endedness to it. And it's sort of about those sorts of decisions. But for data shader, this is a lot more prescriptive. It's pretty much using a unique approach to show something like this. So there's going to be less variability in what's expected, but this is more just making sure that you guys get to play with data shader. So what I chose here is what's called a bivariate choropleth map, and so read through this post. But basically, what this is showing us is sort of mapping out two variables, and really getting sort of sort of mapping these two variables and getting kind of this square-like color scale where you have where you're sort of looking at sort of comparisons between these two variables and how they map out in a choropleth. And for something like this, you're not sort of worrying about and the blog post goes into things like population effect, which make things pretty difficult when you're dealing with geographic data like this. But this totally bypasses that and ends up fitting pretty nicely with the sort of question that we have here. And we're past time, but does anyone else have any questions on assignment 2 or on anything else with the course? Cool. So good luck on module 2. I'm behind on posting the meetups, but both of these meetups will be posted in the meetup link on Blackboard. And good luck. Data Shader is really fun, so I hope you guys enjoy this. Cool. Thanks a lot, everyone. And I believe we have some people from the second section coming in, so we're just finishing up with the first section, so we'll get started momentarily. So I'm going to stop presenting and we'll get started shortly. All right, so for everyone joining from the second section, welcome, and we'll be getting started shortly. All right, so welcome everyone to our second meetup. Simon, so I haven't posted the first meetup video yet. I'm a bit behind there, but that will be posted as soon as possible. Sorry for the delay there. And that'll just be in the meetup info link. The meetup, yeah, the meetup info section of Blackboard. So I'll give everyone a minute or two. I'll give everyone like about 4 minutes to join. Any questions before we get any other questions before we get started? So Simon's asking when the second module is due. That's going to be due in 2 weeks, in 1.5 weeks. It'll be due not this Sunday, but next Sunday. Let me just double check. Are you guys seeing? Am I in the wrong? Hold on. I was in the spring term. I thought I had the wrong dates for everyone, but I was in the wrong semester. So yeah, it's going to be due September 29th. And that should be in the content module, in the content link for module 2. All right, so we'll get started now. So welcome to our second meetup. So for our last meetup, we had, because it was before all of the assignments, it was a bit more new content heavy. For a lot of the future meetups, it's going to be mostly talking about our assignments, going over previous assignments, and introducing the new assignments. And but as we get on to especially some of the later modules being more focused on web development concepts as we're working on Shiny Dash and eventually when we get into JavaScript, the I'll add some diversions for content about just conceptual ways of thinking of these sorts of web development concepts. But for this, since now we're still dealing with just more static visualizations in R and Python, we're just going to be focusing on the assignments so far. So let me share my screen. And is everyone seeing my screen? Perfect. Cool. So, so first we'll just be going over the first assignment. I got a chunk of the first section graded. Unfortunately, I didn't get up to anyone in second section yet. So I think unless some people are coming from have switched times, you guys probably didn't see anything graded yet. But so far, what I've been seeing, a lot of really great stuff, some interesting takes on these questions, and here we'll go through a few options of how someone could have answered these questions. So first, just looking at this data set, we're looking at the Fortune 500 companies and just looking at some various stats on them. So a pretty traditional tabular, multivariable data set. And here you're getting kind of a summary um, of our data, and more importantly, looking at the head where we begin to see what the data actually looks like. So important for these questions and for sort of any data exploration, the first thing that you're kind of wondering is what sort of what does each row represent? What is each data point? And in this case, it's each row is a company. So this is going to come into play when with some of the questions, sort of we're looking at different angles of it'll inform some of the future questions. And and then we're just getting rid of some A's and A's and then moving on to our questions. So our first question is a very straightforward one. We're just simply looking at the distribution of companies by state. So, pretty much all we're looking at is we have a bunch of companies by state, and we're just simply looking at counts. So, first taking a naive approach, and in these questions, you'll sort of see a sort of exploratory workflow, and this should be very familiar and will be very similar, like as you sort of deal with any new data set. You sort of just do your initial exploration to see what exactly it is you're dealing with. So first, naively, we're looking at counts. Bar chart is a good way of showing that. and we're just simply plotting all of this out. So we're just making sure that we're getting our aggregation, and then plotting everything out, um, plotting everything out here. So the first thing to think of with this naive approach is look at one of the things that will be asked in question two, which is what is the third, what's the state with the third most employment? That is something that's more difficult to answer in a sort of using a graph like this. You could, we have enough variation, especially at the higher employment states, to pretty much drill down to what we're looking at. We could kind of do the visual. Um, we could deduce this visually ourselves, but it's not ideal if you're looking to sort of get that information from a visualization like this. And the easiest way, and this is obviously like very common when you're just simply looking at a bar chart like this, is to just reorder your data depending on reorder your data descending. So here and here I didn't do any theming, so there's still grid lines, still sort of superfluous ink, but this is the simple reordering of the bars is an example of essentially more information that we're getting for free. More information that we're not adding any more ink. Like if we're just simply thinking of maximizing that data to ink ratio, we aren't adding any more ink, so we're not adversely affecting our ratio. But just by simply reordering the bars, you end up getting that much more information. We'll see a few examples of this as we go down, but when one of the things to think of when you're looking, sort of maximizing data to ink ratio is a nice concept to really guide the efficiency of your visualizations. And most of the time, you sort of think of it as just completely superfluous elements. Something like grid lines in certain contexts, it might not be superfluous. It might depends on what you're looking to show, but you could sort of think of lots of other examples of just purely superfluous graphical elements. But when we're but as you sort of get to a more minimalist state, you begin thinking of these questions in terms of trade-offs. We'll sort of more get to the point of trade-offs, like more clear trade-offs where there actually is some ambiguity on to what the correct what the best choice visualization choice is. But for something like this, it's really essentially a free trade-off, something that there's nothing lost by reordering the graph and by reordering that axis, but in this case the y-axis, but we end up gaining that much more information. So and then lastly, the question was asking to specifically orient this for a portrait screen. So, so in that case, the best way to do that is to just simply reorder the bars. So ggplot has a function called coordinate flip, which just lets you do that. And then I'm using a useful library called ggthemes, which pretty much takes care of the grid line styling, so it deals with the pretty much getting a nice minimalist style there. So the first question It's pretty straightforward, unless anyone has any questions here. Does anyone have any more questions?
Um, yes, hi, I have a question. This is Simon.
Mm-hmm.
Um, so I had a similar graph that you have, but I was looking for a way to spread the shortcuts for the states. Right now, they kind of clumped together too much, but I couldn't find any way. And also, I wanted to kind of change the height and width uh, of the chart to make it more portrait looking,
Mm-hmm.
and also couldn't find a way. So I was wondering if you know a way to do that. So those two things.
So yeah, and actually, this was asked in the previous section as well. So I might try to add some wording because I hope there wasn't too much time wasted on trying to get the height and width correct. But really, what I was looking for in terms of the portrait orientation was just a visualization that if um, if it were in a in sort of that orientation, it would work with ggplot. And as we get into plotly, a lot of these visualizations are context dependent. So whichever window you put them in, it will dynamically resize itself to fit. And a lot of times I like there are way and I told the previous class and I'll include it in and Simon, if you want to ask that in the ask the instructor forum, I could provide the content, the syntax of how to set the height and width. But I normally try to avoid using set heights and widths. And this will become more apparent as we're um, once we start dealing with frameworks like Shiny or Dash, where we have multiple visualizations and and then I mean, obviously this is more data science oriented, but if if you were a web developer, really you're trying to make whatever you're designing work in whatever orientation a user happens to use it in. So, you're concerned with responsiveness and, sort of adaptiveness in, so either having your design be able to work in multiple formats or have something that sort of formats itself. So, looking at the graph itself. So, looking at the graph itself, um, really, and what we could do is go back to R here, um, and we'll actually run some of this. So here, if we open this up in a separate window, you'll see that the, you know, it is responsive to the size, and this is some more what a user would experience in a portrait oriented format. But it's, rather than sort of define the height and width exactly, um, I usually tend towards keeping the responsiveness and then, really, as we're dealing with more interactive visualizations that include, or, really interactive apps that include multiple visualizations, you want to be able to control what the graph looks like depending on what container it's put in. Um, so, uh, so yeah, I hope too much time wasn't wasted on that, and I'll think of rewording that for the future. But really, in general, set heights and widths are something I like to avoid.
Okay.
Cool.
Um, just a little bit of follow-up. But
Mm-hmm.
if your intended output is PDF, and you want to avoid, let's say, those abbreviations for states to be clumped together, in that case, you would suggest maybe controlling the height, so in some way.
If you're thinking of PDF, then yes. And PDF is something that you know what it's going, like you're using knitter and um, generating your PDF using that. So, that would be a case where you would use sort of predefined height and width.
Okay, thank you.
Yep. Yeah, the way to think of it is like in a PDF or something similarly static, you aren't, the like you have control over the layout. So if you want something like if you want a graph like this to take up half of your page, that's something that you would want to do using set heights and widths. Whereas, and you knew your page was always going to be the same size. Whereas, in like I'm thinking of this more in terms of a sort of if this were on a tablet and someone had an iPad versus someone else who had a Galaxy tablet or something like that, and they have different ratios. You know, on each of them, the graph would be showing up slightly different. So what really matters is it's it's meant to be used in more of a full size portrait mode. So really, the point of the question was making sure that was getting the chord flip, but yeah, these are all very good points in terms of sort of setting that height and width, and then thinking of it in terms of a more static document.
Okay,
And
thank you.
yep. Any other questions? Cool. So for question two, and here, we're looking at the third most, the state with the third most companies. So something like this lets us pretty easily deduce that it's New York. And in this case, we're looking at how many people are employed by companies in these different industries. And, I sort of um, uh, mentioned that we're looking at either average or median employment, but because we're asking a question about industries within a state, and we're and really our data is keyed on companies, where we want to get an idea of the variability within each industry. So, and in the assignments I've already graded, there was some, sort of slip ups here where people would use a similar approach to above, like using a bar chart and just showing that average or median. But, one thing to really think of when you're looking at data sets like this is, it's multidimensional, and you're not just looking at these sorts of aggregates. Mean and median in this case are aggregates. You're looking at what the behavior within each of these categories is. So there's a bit more that you would need to show aside from just looking at a single measure for each industry. And for data like this, the first thing to really that I would recommend really trying is just looking at a scatter plot. And here we're just kind of naively plotting everything out. So we're just, we have something pretty simple here. We're keeping the same layout where we're flipping our coordinates, but we're just simply mapping industry and employees, filtering by state, and seeing what happens. And we notice a few things. So one of the things I mentioned in the question was dealing with outliers, and it is pretty clear that, oops, sorry, and it is pretty clear that we have some outliers. And, so really what these outliers are doing is not allowing us to get any more insight into what's happening with the vast majority of the data. With these data points, we're not really able to see the distribution because it's so skewed by these outliers. And there are a few ways of dealing with this. So, one of the really sort of the first way to kind of deal with this, kind of a naive approach to looking at this, and this works if something is truly an outlier. So, if there's just one data point that is so far out there and it's throwing off the entire visualization, you could just simply clip your data. So, what I'm doing here is with this function, I'm using sapply to return this to essentially apply this function to my list. And all I'm doing is just returning either this is sort of a shorthand way of doing it, but really all I'm doing is returning either the value or 2500 if it's above 2500. And then once I plot that out, you could see that here we're getting no information. Here we're getting a bit more information about what's happening down here in the majority of the data points. So we're seeing a bit more context. And the thing is, though, we are still seeing clustering we're still seeing clustering towards lower employment companies. So does anyone have an idea as to, if we're clipping data and we still see clustering, what that might be suggesting about the data? And to kind of continue what might be happening here, imagine if I looked at something like this and I decided that I want to clip my data here at 1250, and or I mean, really, that's not sort of a good place to clip it because even there, you would end up with outliers. But basically, the so what's happening here is pretty much we could continue clipping this data and we'd probably still end up with similar distributions of the data. So that's suggesting that there is a skew to the data. It's not just there is some other distribution happening. So in this case, it's sort of an exponential distribution of the data, and the and so here I just decided to sort of stick with clipping the data. But in grading the homework assignments, I saw that some students decided to use a log transform on the x-axis, and that's a really good way of. So if we were to use a log transform, we don't even need to worry about clipping these first two outliers. All we really need to do is apply that log transform, and we end up with data that looks pretty normally distributed. And so this is sort of touching on what I had mentioned before about how these like as you're making choices in your visualizations, sometimes there's just simply cut away the excess in service of efficiency, but sometimes there are legitimate trade-offs. So if you were to plot, and anyone, it is totally valid to use a log transform in this case. Definitely uh, anyone who chose that, um, that's spot on. But it is still a trade-off because what you end up losing is the sort of intuitive, um, essentially the intuitive way of seeing what actually is happening with the data. So, if you have the log transform, you'll see um, more normally distributed data. You will better be able to see the like. So one of the drawbacks of this of data with this sort of skew is we're not able to see really what's happening at the lower end. We sort of look at a visualization like this and we see there's a bunch of data clustered in the lower end. There's a bit less on the upper end. And but if we wanted to say, among smaller companies, how does travel and hospitality compare to environmental services or compared to consumer products? And something like that isn't really available to find out with a visualization like this, but it is available with a log transform. And then the trade-off is with a log transform, you end up losing, the ability to really see, what the underlying distribution is. You sort of have to take that extra step to realize this axis has been transformed and there's, the distribution does not actually look like what I'm seeing in front of me. I need to do some extra work to, sort of take a single category or take all of them as a whole and objectively map that onto what's actually happening. Um, so in that case, there's a trade-off between those different ways of dealing with the data. But in this case, we're just simply clipping the data and only clipping away these outliers. We still have information about what's happening with the lower end of companies here. And so, as I had already shown by scrolling, we're looking at something like this. It's technically giving you the information that you need, but there are visualizations out there that are more specifically tailored to show distributions of this sort, and one of them is a categorical box plot. So over here, really in this way, you could think of a box plot as kind of a special case of a scatter plot, where we're taking, these areas of the distribution and we're replacing them with these shortcuts. And this really gives most of the information that we're seeing up here. So we see the skew of the data, we see the rightward skew of the data, we see we sort of could gather at the exponential distribution based on what's happening. I personally think that a box plot gives a bit more information about what's truly happening with these distributions. So there's sort of all of the, I would say like most of these industries are somewhat exponentially distributed, but there's different skews to them. So for media, for example, it's you don't have that many outliers, whereas if you look at human resources, you have a lot more. So it's so I personally think that that's shown a bit more clearly with a box plot like this. then lastly, um, we're just adding some extra context with those outliers. So we're labeling we're labeling those outliers to make it clear that things that were clipped were actually happening further out on that axis. So so box plots work really well as a sort of standard visualization type. It's really good at dealing with distributions in this way, but there are also custom visualization types that we would be able to create, and these sort of get more at kind of base level ggplot concepts. So so here, the kind of hypothetical I mention is with box plots, you have your interquartile range, you have your the whiskers are 1.5 the interquartile range, you have your median being highlighted rather than your mean, which in most cases is what you want to do because means are skewed by these larger values. So especially in a case like this, medians work well. But imagine if you wanted to highlight the mean, and imagine if for some reason rather than using interquartile ranges, we wanted to use standard deviations. You would be able to create a custom visualization using ggplot that does that. So here, what we're doing is uh, looking at our various, and actually I ended up using quantiles here. I thought I used standard deviation. But we're sort of pre-calculating things ahead of time. So we're looking at we're sort of using an aggregation here, and we're summarizing with our mean, standard deviation, median, lower, and upper quantiles. And then we're using a ggplot concept called point range. So here, point ranges are usually used as error bars. Like that's usually the way that you think of them in terms of variability of measurement. But in this case, we could use it to display a distribution, which really is what error bars are showing. But in this case, we're doing it more precise, more in a different context than it's usually used for. But by using these more base concepts, just using geom point, we could create something like this, where we, it's a bit more pared down. We're still getting information about the means. We actually see something like that a bit more clearly, it could be argued, than someplace here. And we also get information about that distribution. So we see the we see the mostly skewed distributions here. We actually see a bit more clearly the cases where it's not skewed. So we have some weird edge cases here, which we may want to explore later on. But we see our rightward skew, and this just gives us a different way of visualizing that. And then alternatively, we could look at this as error bars on a bar chart. So there's a ggplot concept for a geom error bar, which is showing us this here. So any more questions on this before move on to question 3? So Simon's asking if this will be available on GitHub. I'll I don't think I want to put it on GitHub because the history is there, and I use that for multiple for I use that sort of in later semesters, so I don't want that history to be there. But I'll find a way to share this with everyone. I'll try to post links in the content sections of Blackboard. Anything else? Cool. So for our next question, we had a similar approach, the question sort of demanded a similar approach. It's asking, it's looking at a different measure, but it's really we run into a similar problem to what we had with question two, where we are looking at a measure per industry, and we want to be able to get information on the distribution of the companies within that industry. So one strategy would be just using box plots, similarly to what we used above. So here, I'm not accounting for outliers just yet, but this is kind of a naive approach at looking at a box plot. So the only really thing to note here is where, and this is sort of the old and new way of doing things, although with some of the assignments, ggplot has been sort of integrated a bit more tightly with dplyr. So there's some really cool patterns I've been noticing where in some other students' assignments where you're able to sort of combine your aggregation and visualization steps, which I found really interesting. And but in this case, we're sort of using dplyr to create um, our measure, and then just plotting it out using boxplot, which is almost exactly the same as what we did before. But one more alternative way of looking at this sort of data is what's called a kernel density plot. And this uses this is using the principle of small multiples. We're talking about that in our discussion this week. And this is, so, there's a built-in function to do this, geom density. There is we're doing this facet wrap. So we're, just looking at various facets by industry. And in this case, we are looking at a log scale to make these distributions more normal. And, so we are seeing, so here, this kind of, in my opinion, gives a more clear example of what the benefits of using a log scale is, where, we're able to sort of look at the data as if it's normally distributed, get information about what's happening in lower employment companies. And more importantly, this really allows us to do comparative exercises. So it allows us to look at something like health versus government services and get sort of this, very tight distribution versus one with more spread, and or to see distributions where we might have bimodality, something like real estate, or even something like food and beverage. You kind of have that happening with the smaller companies. And especially with food and beverage, that would be invisible pretty much if we were looking at exponential distributions. And, I think this adds more information, but, there is a slight trade-off here where if you were looking at these distributions, that's not what's happening in reality. This works in a comparative way, but it doesn't work as well in a absolute style. And one thing to note about about using geom density is this is pretty much what a violin plot is. If anyone has come across that, a violin plot is a kind of similar visualization to a box plot, but it use rather than marking the just having a box like this, it displays the kernel density as kind of a two-sided um, shape that usually looks like a butterfly. And as I mentioned, unfortunately, I didn't get up to the second section yet, but I'll be grading that before assignment 2, so you'll have some of my comments to work off of. But what I've been noticing so far, a lot of interesting takes on these. So, um, does anyone else have any other questions on this assignment? Cool. So in that case, we'll move on to assignment 2 and what'll be expected there. All right, so for module 2, we're going to be moving to Python, and this module is serving as really serving two purposes. The first just being visualization in Python, and specifically using in this case Jupyter notebooks versus RStudio. But secondly, this is also serving as an exercise to deal with large data sets um, and two strategies in how to visualize these large data sets. So um, so firstly, just to get a handle on everyone's experience with Python so far. Like I know everyone here has taken 602, and from the last section, it seems like notebooks were introduced towards the end. So is it kind of an assignment or two that everyone was working with notebooks? Does anyone have any further experience? Or I know in previous semesters, the instructor for 602 either changed or but the so some people may have uh, different experience with 602. But in terms of everyone's Python experience, what would you say your level is at? Medium, cool. Is that like outside of 602, or are other classes using Python? Okay, so yeah, Peter, it's outside. Cool. Cool, yeah. And that's actually one of the reasons why I try to focus on Python, try to make sure that we sort of get the Python fundamentals, because I found with a lot of the courses it's pretty R centric, and just in my career I'm like mostly client facing, so I see a lot of what's out there, and just there's in my experience a lot of Python out there. So I definitely want to make sure that 602 isn't the only experience people get with Python. So hopefully with this, and as we're working with Dash, this will give you a bit more exposure to Python. But if you are used to working with R, Python, for this module specifically, the pandas, which are Python's version of data frames, is a bit different than what you would experience in R. So down here in the notebook, I included a little cheat sheet for meant to really compare pandas data frames to R data frames. So, this is really meant for, if you're very comfortable in R and, you're sort of trying to get a handle of pandas and are just struggling with the differences. It's not really sort of the concept of data frames, but it's more just why is this different than R data frames. I tried to really frame things in that way. And there are a lot of kind of weird differences. Pandas deals a lot more with indices, whereas in R you're not really dealing with that, and because of that, there are a few more things to take into account. And this is a personal preference of mine, but I like to reset the index of group bys, for example. If you group by in pandas, you end up with especially with multiple variables, you end up with a hierarchical index. And a lot of times you just simply want a similar data frame as before, just aggregated. So this gives you a more R-like experience. And then just going through a lot of other concepts. So I included some of the links to the Pandas docs, and in general, like this should serve as a nice starting point, but just sort of keep that in mind as you're exploring Pandas on your own. So for Module 2, we're going to be working with what's called the Pluto dataset. So this is this is a data set that includes every single tax lot in New York City, and the link is provided here. It's too big to be uploaded to GitHub, so just download it and match the paths. I think you'll have to change these to version 18, but once you do that, you should be able to just read them all in, and this will concatenate it for you. And then just remove some of the outliers. So, basically, with something like this, the main problem that we're looking to solve is, what sorts of strategies do you need to use with large data sets? So, as an example, and this is using Plotly's docs as an example, a lot of times you're able to graph things, but it may not make sense the way that you're graphing them. So in this case, Plotly has Plotly is always interactive, but it uses a technology called WebGL to deal with more with larger numbers of data points. So here we have sort of on the order of 100,000 or a million data points. We're able to plot this out, no issue. We're getting the sort of interactivity we want. It's sort of fine from a technological standpoint, but this isn't really succeeding as a visualization. So what this is just a binormal distribution, but we're not really getting any, really there's sort of a cutoff here where the points become dense enough where it's just a mush of points. And, we aren't really able to tell what the difference between this region and this region is, for example. We get some additional context, like with Plotly, especially because there's interactivity. So I could do something like this and, continue to zoom in. Didn't really want to do that, but like you could sort of pan around and, get an idea of how the points are getting denser as you move more towards the center. But you're still losing a lot of information by plotting things in this way. And some of the more, really the traditional way of dealing with large data sets like this is using techniques such as binning and aggregation. So um, So this is looking at the same data set. It's the same binormal distribution, but we're getting a bit more, in some ways, a bit more information about it. We're able to see that, the central region is has more points. So we're able to kind of see that this region has more points than this region, whereas in the previous visualization, this whole thing was kind of a circular boundary that we weren't really able to gain more information on. And I mentioned partially because technically what we're doing is we're losing resolution. So, we're, and I'll get into in a bit, what that means. But, really it's because we're binning things, like we're losing a bit information about what's happening with the outliers. So so that example, and as I mentioned in the sort of context here, we have visualizations where binning is inherent. Things like histograms or 2D histograms. So if you imagine, if you're building a histogram, one of the parameters you're able to set is your bin size. You're able to decide, a do you want a large number of small bars or a small number of large bars? You're able to sort of set your resolution depending on what it is that you want. The and then similarly with 2D density plots, what I mentioned. So that's one way of thinking of binning and aggregation, but you could also use these techniques to end up with more traditional visualization types. So something like just a line graph in this case. So as I mentioned, this is showing every single tax lot in New York City, and this first cell is just looking at an aggregation over time. So how many buildings were built per year, um, and and we end up with something weird. So this is going to be part of the assignment, but there's this isn't the cleanest data set, so part of this is going to be kind of you know strategizing around the limitations of the data set. So um, you know here there's an obvious limitation that is or there's a limitation that is sort of preventing us from seeing what's truly going on with the data. So that's part of what we're doing here with that first question, just looking at strategies of binning and aggregation and what sorts of visualizations come up as a result. And the question that we'll be answering is sort of an interesting one, because we're looking at essentially the first, like, if you think over time, as technology improves, we've been able to build taller buildings, but at each kind of step, there's always been sort of earlier taller buildings and later taller buildings. And one strategy in this hypothetical situation that the Department of Buildings is using to inspect buildings is to focus on the first taller buildings that were made. So when we first started building 12-story buildings rather than 3-story buildings, the first times we've done it, probably there were design standards that weren't worked out yet, and these might be resulting in unsafe conditions. So in this hypothetical, that is why the Department of Buildings would be interested in that. Similarly, for sort of the first times that we breached 20-story buildings, or when we began building 30, 40, 50-story buildings. And so what this is really looking at is trying to find a way of localizing those first tall buildings, like of that class, and really checking those buildings. So I'll leave that to everyone to sort of think about. And then the second question is uh, is using a library called Datashader, which it's a really cool library. It has a really interesting take on the problem of dealing with large data sets. And what it so what Datashader sort of looks at is it starts with a problem like this, where we have where we're plotting out WebGL, sort of WebGL points, and just simply the technology that we're using, or the sort of choices we've made here, is resulting in the visualization not really being truthful, not really showing us what's actually happening. So in this case, it's obscured the difference between this region and this region. And then in the documentation, in particular, the plotting pitfalls, which really gives the purpose of Datashader. It shows the sort of driving force behind it. And you'll see some other examples. So for example, here, if we plot these two data sets over each other, the choice of which data set is on the bottom and which data set is on the top informs what the visualization looks like. And kind of one rule of thumb is of sort of judging whether a visualization is accurate or not is something like the order of the categories shouldn't be affecting what the visualization looks like. This is the same data, and yet it looks drastically different. A user, someone looking at this graph would be drawing two different conclusions, and that's not a successful visualization. This isn't something that is, really sort of showing what's happening in reality. And it shows similar examples with overplotting. So you could sort of see how you end up with just a blob when the points get close enough together and you lose all resolution there. And that's not really what we're aiming for with a visualization like this. So you could kind of deal with this a bit by fiddling around with the opacity. This would work in an example like Plotly's. So the example's not there, but here you could see that with both of these graphs, they're more similar than they were before, but there is still some difference. Like here, there is a bit more blue. Here, there's a bit more red. There's sort of still some weirdness going on there. And Datashader was created so that you could just throw these points at it, plot it out as a scatter plot, and it essentially dynamically deals with this automatically. You don't have to worry about, really setting your bins, thinking about how these dynamics are working out. It gives you some other techniques, some other measures to toggle, but you're not really thinking about that that much. And then so using this as an example, if we're looking at sort of a first brush naive approach at the first question, year built, and comparing year built and number of floors, if we were to throw it into a heat map, we get something that looks like this. So we're able to see roughly buildings are getting taller over time. We're kind of able to see, some general patterns of what's happening. We're able to see that there are a lot of shorter buildings, but there's not much that we're able to make out with something like this. With Data Shader, what we could do is, give it the same data. I'll quickly go through what this is doing, but the docs will sort of go through the pipeline that Data Shader uses. But in essence, you're pretty much just throwing data at it, and it gives you, it sort of chooses how to deal with these these weird regions. So it's dealing with the denser regions by adding by sort of adding these color gradations. It's dealing with the sparser regions by treating it like any other scatter plot by just simply plotting out the points. And Data Shader does this all automatically for you. So we sort of spend the first question looking at strategies to bin data and deal with larger data sets. And then once we get to Data Shader, that's kind of meant to be automatically dealt with. It's still a relatively new library, so there is still, it's still, I would say, like kind of a more cutting edge sort of um, strategy, but it's definitely really cool. Definitely something to fun to sort of use, and it shines a lot when you're working with geographic information. So here we're just simply plotting out the latitudes and longitudes of the tax lots, and we're getting the density of buildings. And this is important, kind of interesting that it gives kind of weird results that, for example, in Midtown, it looks like we have, the densest part of the city, we don't have that many buildings, but in reality, what's happening is the buildings are just bigger. So a tax lot could be an entire block in a lot of cases, but what's not being shown is there's a gigantic skyscraper sitting on that block. So you're able to look at something like this and get a really nice automatic sort of density map that you wouldn't really be able to get using other methods. And I didn't update the notebook yet but I added this to the content, the actual data shader documentation. But I linked to a few examples, like example notebooks that data shader uses. So the US Census one in particular is a pretty useful case study to kind of work through what you would be doing for this assignment. Um, So this goes through a few examples. Here you can see we're adding a categorical variable, and we're able to get some pretty cool views of sort of the US as a whole, or then drilling down into individual cities. And things like dealing with the categories, making sure that we're not, the order of the plots don't matter, so that you sort of have more diverse areas of the city showing up as sort of gradations rather than just simply one color showing up over the other. And then for this question, it's a bit more prescriptive. So it's I'm pretty much laying out what will be expected here. We're sort of looking at two measures in Pluto. We're looking at the assessment of the land and the assessment of the structure. And we're sort of looking at, we're pretending we're a developer, and we're trying to look at underbuilt areas of the city. So you could think of, conceptually, if you have valuable land, that land will be more intensely developed. In the center of the city, you'll have skyscrapers. In the outskirts, you'll have single-family homes, just because the the land is more valuable in the center of the city. And what we're trying to look at are using these measures in the Pluto dataset, we're looking at where there are some discrepancies. So where either, and as a developer, you would be more interested in areas where the land is expensive, but it's underdeveloped. There's not really an expensive structure there. And one of the techniques that we're using is a sort of unique take on a choropleth map, looking at bivariate choropleth maps. So so basically, this post and the author does a really good job at kind of explaining some of the drawbacks with choropleth maps, how population dynamics could end up overshadowing what you're actually looking at, the patterns per capita. And if you're looking at two variables, how something like this could end up giving you more insight. So, here we're comparing Bigfoot sightings with population, and making sure that you know if we have larger populations, you're gonna have more Bigfoot sightings just simply because there's more people there. But this gives sort of the clearer pattern, which would make more sense, which is like in rural areas, mostly in the West Coast, although for some reason in upstate New York, you're seeing Bigfoot sightings. And similarly, this works out really nicely for the for these two variables that we're looking at here. So any questions on this module? Or any other questions about course logistics, anything like that? Cool. All right, so good luck on this module. As I mentioned before, I'm a bit behind on the recordings, but I'll post these as soon as possible. And good luck, and thanks a lot. Good night, everyone.